Hello students, today we're going to learn to display distributions with graphs.
Don't take too long.
So, a data set contains information about individuals and variables. Individuals can be about people, animals, or things. The data gives a value for one or more variables. Variables can describe key characteristics of individuals such as a person's height, gender, age, or salary. Calculatory data analysts use graphs and numerical summaries to describe the variables in a data set and the relations among them. Some variables are categorical and quantitative. Distribution of a variable describes what values a variable takes and how often it takes these values. To describe the overall pattern of a distribution with center, spread, and shape. Some distribution can be described with shapes such as symmetrical and skewed. This one is the histogram of skewing to the right. Skew is when there is like a long tail. Example of skew to the left. Symmetrical is when, for example, it's a histogram and, basically it will show like a mirror image. What's that smell? Michael, put your shoes back on. Speaking of socks, to describe the overall pattern of a distribution with center, spread, and shape, we use socks. S is for spread, O is for outlier, C is for center, S is for shape. Another type of graph is histogram.
Antihistamine?
No, histogram.
A histogram is a graph of the distributions clear if nearby values are grouped together. To interpret this graph, the center is at age 55. The spread is between age 42 and age 69 as the oldest. The shape of the distribution is roughly symmetric and has a single peak. There appears to be no outliers. A histogram does a good job of displaying the distribution of values of a variable. But if you want little information about a relative standing of an individual observation, you will like to construct a relative cumulative frequency graph, often called an ogive. To construct an ogive, also known as relative cumulative frequency graph, first step 1, decide on class intervals and make a frequency table. Just as in making a histogram, you need to add 3 columns to your frequency table. 1. Relative frequency, 2. Cumulative frequency, and 3. Relative cumulative frequency.
To describe a distribution, it begins with a graph. Bar graphs and pie charts are good to describe categorical variables. To describe a distribution, it begins with a graph. Bar graph and pie charts are a best way to display categorical variables. Categorical variables places each individual into a category like male and female. In this case, it will be soft drinks. Graph quickly compares the soft drink sales of the company. The height of the bar shows a count and 7 categories. You can tell this is a bar graph by the space between the bars. To construct a bar graph, you need to label your axis and title your graph. The axis, label the horizontal axis, company, and the vertical axis, cases sold. And then you title your graph. Scale your axis by using the count in each category to help you scale your vertical axis. Write the category names at equally spaced intervals between the horizontal axis. Then draw a vertical bar above each category name and a height that corresponds to the count in the category. For example, the height of Pepsi Cola Co. should be at 3,119.5 on a vertical scale. That's how you display a completed bar graph. A pie chart helps us see what part of the whole each group forms. For example, Coca-Cola Slice makes up 44.1% of pie because the Coca-Cola Company sold 44.1% of all soft drinks in 1999. How to construct a pie graph. Simply, you can use any computer, a statistical software package, and many spreadsheet programs will construct these plots for you. But in this case, you can do it yourself as well. A pie chart makes up a whole, as in 100%. All these numbers can be added and they will equal to 100. It is important to have a key that displays all the colors, so when you construct the pie graph, it will show up.
Oh, I'm so hungry. When does lunch start?
Dot plots and stem plots are a great example of displaying quantitative variables. These graphs are great for large data. Step 1. Label your axis and title your graph. Then draw a horizontal line and label it with a variable. In this case, the number of variables would be number of goals scored. Step 2. Scale the axis based on a variable. Step 3. Mark a dot above the number of horizontal axis that corresponds to each data value. Sometimes the value of a variable are too spread out for us to make a responsible dot plot. We can consider another simple graphical display, a stem plot. This data contains spread from 15 to 47 mg for these soft drinks. A stem plot might be preferable due to a large spread. To make a stem plot, it requires step 1. The stem consists of all but the rightmost digit and the leaf contains the final digit. Step 2. Write the stems vertically in increasing order from top to bottom, then draw a vertical line to the right of the stems. Step 3. Rearrange the leaves in increasing order from the stem. Step 4. Title your graph and add a key describing what the stem and leaves represent. When you examine a time plot, there are two common overall patterns. There are trend and seasonal variation.
An outlier are observations that lie outside the overall pattern of a distribution.
So, Michael, thanks for tutoring me.
No problem, Julie.
Okay, let's start.
So, you need help on chapter 1.2, right?
Yeah.
Okay, so to start off, to find the mean of a
Oh,
set...
mean? Like that mean witch Diane who always talks to you?
I guess, to find the mean of a set of observations, add their values and divide by the number of observations.
Okay.
If n observations are x1, x2, and x whatever, 3, 4, 5, their mean will be x1 plus x2 plus all the other variables all over n. Next is the median, or m, which is the midpoint of distribution, the numbers such that half of the observations are smaller and the other half are larger. To find the median of the distribution, there's 3 steps. First, arrange all observations in order of size from smallest to largest. Second, if the number of observations m is odd, the median m is the center observation in the ordered list. And 3, if the number of observations n is even, the median m is the mean of the 2 center observations in the ordered list. Because the mean cannot resist the influence...
Resist? Like your irresistible eyes?
Yeah. Resist the influence of extreme observations, we say that it is not a resistant measure of center. One way to measure spread is the range, the difference between the largest and smallest observations. Calculate quartiles.
Oh, like basketball courts, right? Oh, I love sports. Don't you?
Not really.
Oh, me neither. They're stupid.
Well, to calculate quartiles, 3 steps again. First, you have to arrange the observations in increasing order and locate the median. Second, the first quartile, or Q1, is the median left of the overall median. The third step, the third quartile, or Q3, is the median right of the overall median. Following quartiles, you need to know the interquartile range, or IQR. which is the distance between Q3 and Q1. And the formula for IQR is, so IQR is Q3 minus Q1. So the two equations to find the upper and lower cutoff for the outliers would be Q3 plus 1.5 times the IQR, which would equal the upper cutoff. And the second equation would be Q1 minus 1.5 times IQR, which would equal the lower cutoff. And if an observation falls out of these two ranges, then it will be classified as an outlier. Next thing you need to know that involves the quartiles is the 5-number summary, which involves the minimum, Q1, the median, Q3, and the maximum numbers of a set of data. And with the 5-number summary, you would gather those numbers and make a modified box plot. So, a modified box plot is a graph of the 5-number summary with outliers plotted individually and contains a central box that spans the quartiles, a line in the box that marks the median, and observations more than 1.5 times IQR outside the central box are plotted individually, which are the outliers. And lines extend from the box out to the smallest and largest observations that are not outliers. And to measure spread, besides using range, you could use the standard deviation, or S. The variance S squared of a set of observations is the average of the squares of the deviations of the observations from their mean. In symbols, the variance of n observations, x1, x2, x3, or whatever you have, is variance equation in a very complex form is this, or a simplified form would be this. Standard deviation, S, is the square root of the variance, S squared, which would be S equals the square root of the variance. Transforming data. So, recall that when we calculate the z-score of an individual observation, we transform that value into a standardized unit. What happens when we transform a data set by adding, subtracting, or dividing and multiplication by a constant? A, or 5 million. You would add A to measure of center, which is the mean or median, and location, which is the quartiles and the percentiles. But this does not change the shape or the measure of spread, which is the range, IQR, and standard deviation. For example, we have these two data sets, the original and the new, where we add 5 to each number in the data set. And when we calculate the 5-number summary and the stat summary, we get these numbers. You can see in the original and the new, the only thing that changes is the 5-number summary, which is the minimum, Q1, medium, Q3, and max. They all are added 5. Adding or subtracting by constant does not change the mean or the standard deviation. To find the mean of a set of observations, you would use the equation mean equals x1 plus x2 plus x is how many numbers you have over n, which is the total observations. And using this data set, you would add 10 plus 30 plus so on over, there's 20 observations. So adding all this, you would get 585 over 20, which would equal 29.25. So the mean is 29.25. Another measure of center would be median. The first step to finding median is to arrange the set of data into lowest to greatest, and then if the number of observations n is odd, the median m is the center observation in the ordered list, and if the number of observations n is even, the median m is the mean of the two center observations in the ordered list. So since we have an even number of observations, the median will be the two center observations in the list. So we would count to 10. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And then 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So you have 20 and 25. You would add these two observations and divide by 2, which would equal 22.5, which would equal the median. To find quartiles Q1 and Q3 of a set of observations, you would first need to arrange your observations from least to greatest, and then find the median, which would be 22.5 right here. And Q1 is always to the left of the median to the left of the median. So since we have 20 numbers, it would be 5 numbers to the left. So 1, 2, 3, 4, 5. So it would be 15. And Q3 would be 5 numbers to the right. So 1, 2, 3, 4, 5. So 40. And continuing this, to find the interquartile range, or IQR, you would use the formula IQR equals Q3 minus Q1. So the IQR of this set of observations would be 25. So using Q3, Q1, your min, your max, you would sum it up to do a 5-number summary, which is the minimum, quartile 1, the median, quartile 3, and the maximum of your set of observations. So based on our set of data, we can tell that the minimum will be 5, the max is 65, and we calculated median was 22.5. Yes. So our 5-number summary would be 5, 15, 22.5, 40, and 65. And in order to find outliers of a set of observations, we would try to find the upper cutoff and the lower cutoff using IQR and the quartiles. So the upper cutoff would be Q3 plus 1.5 times IQR. Lower cutoff would be Q1 minus 4.5 times IQR. So, for example, Q3 is 40 plus 1.5 times IQR would be 37.5, which would equal 77.5, which is our upper cutoff. Lower cutoff would be 15 minus 37.5, which equals negative 22.5. So with this data, we can tell that if we have a set of observations that if any numbers fall out of this range, that it would be considered outlier. For example, 78 or negative 655. So based on our upper and lower cutoff, we can say that our set of data does not have any outliers at all.